Okay, I'm back, and I'm still on page 212, I think, and we just did a limacon that did not have an inner loop. And we want to talk a little bit more about why it didn't have an inner loop. Also, I was pretty self-conscious about this graph. I thought it wasn't that good, so while I was gone, I went to GeoGebra to see what it really looked like, and let me just show you really quickly here. Um, So this is what it actually looks like, and we did a pretty good job. So you can see I got my function here, and then I actually use parametrics. We're going to talk about that soon to graph this, or if you've watched other videos from my YouTube channel, you'd probably already know about that. So that's what we're doing. Let me go back here, and I think I got to restart this. I don't know what it looks like on your screen right now. But I'm back, hopefully. Hopefully I never went away. I don't know, it might have been just a giant version of my face for a while there. I'll find out when I watch the video. All right, so there is no inner loop for this particular type of limacon, and we want to really make sure we understand why, right? So the reason you don't get an inner loop is that the curve itself, this curve up here, is entirely on one side of the horizontal axis, right? So I'm going to say there's no sign change, I guess, in the radius. Sorry, I had something on my iPad. So no sign change in the radius. Radius is always, in this case, positive. If the radius was always negative, there would also not be an inner loop. Just think parametrically, you'd be tracing things at different times. You'd be at different points at different times, but you would get the same basic shape. And the closest that we ever get to the pole, this is, think about the rectangular graph when you're trying to answer questions like this, right? So the pole is like the origin, that's when r equals 0. So the closest you ever get is the minimum of this graph. And the minimum of this graph is 4 units away, right? So it's when r equals 4. So you could say 4 units away. That's definitely the minimum. All right, so let's do another example and see how it goes. So we got 8 plus 16 sine of theta. I'm thinking this is definitely going to be mostly on the positive y-axis because it's a positive sine thing. Also, 16 is bigger than 8, so I'm expecting this to have an inner loop. So I like to go in just knowing those sorts of things. So let's see what color. Go with a standard color here. So it's going to be 8, and then plus 6. So I did this wrong last time, right? So let's make sure. So you're at 8, and you can go up and down 16. So if I go up 16, it'll take me to 24. And if I go down 16, it'll take me to -8. And again, my spacing is terrible on these, but I'm just trying to communicate the sign basically and get kind of the general shape. So we got 2 pi, limacons, cardioids, they will always take 2 pi there and there. All right, it's a positive sine graph, so I'm going to start at 8, go up to 24, back to 8, down to -8, and there. All right, and then there, and then there, and there. That got weak at the end, but that's okay. All right, so I know that what I'm going to need to do. Actually, so looking at this graph, right, and just kind of feeling out what's going to happen, this part here, I'm going to shade it. That part is going to be the outer loop. I'll talk about this when we do calculus later in life, but I always feel like outer should have 2 t's in it because inner has 2 n's in it. And it usually you end up with a raging debate about that. Maybe inner should only have 1 n. I don't know. But I always get nervous when I have to write outer because of that. So that's going to be the outer loop. And then, oh, there's a little bit more of the outer loop actually, right? It's right there. And then the inner loop is going to be between these zeros. So here, this will be the inner loop. So what we're going to do is we're going to start out and do almost all of the outer loop, then do the inner loop, then finish the outer loop. So we do need to know, however, when r is equal to 0. So I'm going to do that down here. So if r equals 0, then that means that sine is equal to -1/2. Sine of theta, -1/2. And if sine of theta is equal to -1/2, I'm thinking of the unit circle, so it's going to be theta is 7 pi over 6 and 11 pi over 6. But also, if you're just like, oh, it's a pi over 6, and then you dot in the pi over 6 radial lines, they're in the right place, but we're better than that. We want to make sure that we're actually getting them right. So let's see. So 7 pi over 6, which goes through to pi over 6, which is why pi over 6s are just going to work. And then 11 pi over 6. Go the other way, it'll be 5 pi over 6. All right. So we're going to do the outer loop, right? So you first do the outer loop, pretty much, and then you're going to go back and do the inner loop. So what should I count by here? I'm thinking 4s. If I go by 4s, it's going to work. So I guess I'll do that. I could go by like, oh no, that's still 4s. I was going to say if I like, every other one is 8. Let's try that. Because that's actually how I'm going to label it. So let's say this is 8, and then this would be 16 and 24. Okay. So when theta is equal to 0, r is equal to 8. So we go there. And then when theta is equal to pi over 2, r is actually equal to 24. So that's going to be there. And so I'm going to start here, and I'm going to go out to there. And then when theta is equal to pi, I'm going to be back at 8, which is there. And then by the time I get to 7 pi over 6, r needs to be 0, right? Because this is 7 pi over 6. And we're going to stay until 11 pi over 6. So by the time I get to this tangent line, I got to be at 0. So just curl into the origin. And then I wonder how disorienting it is that I keep moving this around. It might be very disorienting. I haven't actually watched any of these videos. I'm just hoping that they're working out. Okay, so when theta is 3 pi over 2, I need to be at -8. So I'm facing the negative y-axis, but I'm walking backwards. So I'm walking along the positive. I'm going to end up here. So it's going to go like this. And then we're going to sweep back in and then finish. So there you go. Looks a little lopsided as I'm looking at it. But like, I think it's good enough, you know, like it conveys the idea. We know where we are and when. So we were here, this is 8, 0. This was 24 pi over 2. This is 8 pi. And then we're at the origin at some weird times, right? So we're 0, 7 pi over 6. We're here at -8, 3 pi over 2. And then we're back here at 0, 11 pi over 6. And then we finish off at 8, 2 pi. But it's getting a little cluttered on that graph. So I'm going to skip that for now. All right, so now this is going to be, this is not going to go well for me, but I'm going to try it, right? So the constant is bigger than the coefficient. So think in extremes, right? The constant is bigger than the coefficient. So like the constant is 1,000 and the coefficient is 1. You're never going to get an inner loop in that case, right? So in that case, our sine graph, if it's positive, it's going to look like, all right, here we go. I'm anticipating this not going well. There's going to be this point, this point, this point, and like that point. And you're going to go like out. Oh my gosh. That. that, and like that. Not great, but kind of shows it. And then here, we're gonna have like, let's switch it up. Here, here, right? So you'll be, whew, okay, so you're gonna start here, go here, go here, go here. So it's the order that's like really important. And then like this. So is this a valuable exercise? I don't know. It's usually like when we do it in person, there's usually a lot more conversation about this kind of thing. All right, let's say the constant is less than the coefficient. So like the constant is 1, the coefficient's like 1,000. Clearly you're crossing the axis in that case. So you're gonna get an inner loop. So I want a positive sign with an inner loop. Positive sign with an inner loop. So there's going to be, let me start out with some axes. It's probably better if I do them in different colors. Okay, so positive sign with an inner loop. First, you're going to do this point, then this point, the origin, then here. Okay, so I actually like plot those points. That's how I think about it, right? Like point number 1, point number 2, point number 3, point number 4, 5, and then this is actually going to be 6, and then 7. And then we go in that order. So it'll be like this. And you're going to go in. I actually draw those more often than I draw the non-inner loops. Still not amazing. Let's see. All right, so start with this and this. And so you're going to go here. And then what's going to happen is you're going to go here, here. You're going to go back to the origin, and you're going to go out here. Okay, so here I go. It's going to be like this, this, and there's a point way down here that I forgot to do, and then up here. So it's 1, 2, 3, 4, 5, 6, and then 7 to finish. Okay, and then let's do the cosines. And again, this is really just for completeness sake, I think. Like, there's not really a great reason to do this. So I don't know why I just did it that way. All right, anyway, so it's cosine, and it doesn't have an inner loop, so it'd be like here, here, maybe here, here, right? So out, go in, stay in, go out. Something like that. They look sort of like circles, but not like circles. And then the negative one is going to be like, okay, so you're actually going to start like here, like negative cosine. So it starts at a minimum. So like, it'll be something like this. Negative cosine start, sometimes you get yourself confused in life. Like here, oh, but it doesn't have, whew. Okay, hold on there. So here, here. Okay, so let me erase some stuff. It happens. People get confused. Okay, so when theta is 0, we're gonna be like, this is amazing. I'm messing this up this much. What am I doing? Go sketch. So it's gonna be predominantly, all right, I got this. Do I have this? Hard to say. There you go, here, 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 here. I mean, this is gonna be right. Am I doing a good job? Nah, something like that. That's what it looks like. All right, let's do some inner loops and then call it quits on this particular video, which has gone so well for me. So I'm really gonna be sorry to see it go. Okay, so positive cosine with an inner loop. All right, as I mentioned, I actually draw these more often than I draw other things. Positive cosine with an inner loop. You're gonna go here, here, then there, then you'll actually be there, then eventually you'll be there. So we're going to go up, there, there. Remember how confused I got on this one? Man, that was like the end of me. All right, let's try a negative cosine with an inner loop. The weirdest one, right? So I'm going to do it in the strangest color that I have available to me. Actually, the strangest color that I have available to me is the color white. I could draw in white on this. And I think that that's definitely the strangest. So I'm not using the strangest color. All right, so I'm gonna go like this. So that is not black. It kind of looks black to me, but it is not the color black. And then I'll use this. All right, so with this one, you start in the inner loop. Crazy. And then you go here, here, here. All right, ready? So you do half the inner loop, the entire outer loop, and then finish the inner loop. And there you go. All right, so these are like your generic versions of these. It's really useful to know them, despite the fact that I got like stumped on this one. But I'd like to think that I demonstrated what you do when you get stumped, right? As soon as I couldn't figure out what to do, I went back and I just drew one that satisfies the conditions, and I was able to work out what should be happening. So that's it for this video. I will be back with more if I can figure out how to stop this, here we go.